of Mathematics 10, we will be discussing some lessons under probability. That means we need to have basic knowledge of some terminologies and concepts behind probability. Let's start with these four keywords: probability experiment, outcome, sample space, and event. A probability experiment is an action or trial through which specific results are obtained. The result of a single trial is called outcome. The set of all possible outcomes is the sample space, and an event is a subset of the sample space. It may consist of one or more outcomes. Rolling of a die is an example of a probability experiment. It will give us any of these possible outcomes. In a single roll, we may obtain a die of 1, or a die of 2, or 3, 4, 5, or a die of 6. Now, the 6 possible outcomes is our sample space, where each outcome is a sample point. Now, if there's a given condition of having an outcome greater than 1 but less than 6, we can only obtain 4 possible outcomes from the sample space. This is an example of an event. Now, there are various ways for us to determine the total number of possible outcomes depending on a given problem or experiment. First one is counting by systematic listing. This is applicable only for one-part tasks. Basically, we're just going to list down and count the total number of possible outcomes or the options on a given problem. For example, tossing a fairy coin rather. So we can only get heads or tails. There's only 2 possible outcomes. Rolling a single fair die. So there are only 6 possible outcomes. In the next example, we have a sample space N, which consists of Mike, Adam, Ted, and Helen. In how many ways can this group select a president? So we just list down all the options and we know that there are 4 possible results. In your book of New Syllabus Mathematics 10, page 233, there is a particular problem about a traveler who wishes to visit the Manila in the Philippines starting from Singapore. And so if he has a choice of taking any of 3 different sea cruise routes and any of 4 air package routes, in how many ways can he travel from Singapore to Manila? So just like what I have said, we'll list down all the options. In this case, he will have a total of 7 choices of traveling from Singapore to Manila, since he can travel by any one of the sea or air routes. In your book, this is also called addition principle. Another way is counting by table, or product tables for 2-part tasks. So unlike the first one, this is only applicable for 2-part experiments or situations. The first part in this example is tossing off the first coin, while the second part is tossing off the second coin. All we have to do is to get the product of the outcomes from each part. So we know that the first coin has only 2 possible outcomes as well as the second coin. So we'll get heads and heads, heads and tails, tails and heads, and tails and tails. Then we'll just have to count all the possible outcomes. In this case, we have 4. Another example is, what are the possible outcomes of rolling 2 fair dice? So in this case, we have a red die for the first part and a green die for the second part. Again, what we're going to do is to get the product of the outcomes from each part or experiment. So these are the possible outcomes. We'll just count them all. Then we'll get 36 possible outcomes. What if there are more than 2 parts in the given experiment? So we may use this technique, counting by 3 diagram, for multiple part tasks. For this example, find a number of 3-digit numbers that can be written using the digits from the set 2, 4, and 6, assuming repeated digits are not allowed. So the first digit, there are 3 available numbers, 2, 4, and 6. Alright, for the second part of this experiment, we have to choose the second digit. So for the first branch, we can only choose between 4 and 6 since 2 is already taken. For the second branch, we can only choose between 2 and 6 since 4 is already taken. For the last branch is we have 2 and 4 since 6 is already taken. So in the second part, we already have 6 branches. That means for the third part of this experiment, or third digit, we only have one available number for each branch. So for the first branch, we only have 6 since the first 2 digits are already taken. For the second branch, we have 4. Third, we have 6. Fourth, we have 2. Fifth, we have 4. And for the last branch, we have 2. So we list down all the possible numbers. We have 246, 264, 426, 462, 624, and 642. Rather. That means we have 6 possibilities of having a 3-digit numbers using this set of digits. Alright, so again from your book, New Syllabus Mathematics 10, on page 234, there is a problem about Daniel, who lives in Area A, travels by bus to his school in Area B. He must take a bus through point C before boarding a different bus to reach his school. So there are 2 bus services plying between his home and point C. Buses 170 and 171. Then there are 3 bus services between point C and his school. Buses 30, 31, and 32. In how many ways can Daniel travel to school on these buses? So again, we'll use the tree diagram. So from area A, starting from area A, 2 lines are drawn where each line denotes one possible way of traveling to point C. From each of these, another 3 lines are drawn to represent the possible ways of traveling from point C to area B. Therefore, Daniel can travel to school in 6 different ways. For example, he can take bus 170 followed by bus 30, or bus 170 followed by bus 131, and so on. In your book, this is also called as multiplication principle. So as you can see, we can just simply multiply the possible outcomes from this part of the experiment and the possible outcomes from the second part of the experiment or situation. This will lead us to our final way of counting the possible outcomes, which is the fundamental counting principle. It states that if an event has m possible outcomes and another independent event has an n possible outcomes, then there are m times n possible outcomes for the 2 events together. This rule can be extended to any number of events occurring in sequence. So basically, we'll just multiply the number of possible outcomes for each part of the experiment or given problem. So let's have this example. At a firehouse fundraiser dinner, one can choose from 2 proteins, beef and fish, 4 vegetables, beans, broccoli, carrots, and corn, and 2 breads, rolls, and biscuits. So how many different protein, vegetable, bread selections can she make for dinner? So as you can see, we have 3 parts in this given example. We have proteins, vegetables, and breads. There are 2 options for proteins, 4 options for vegetables, and 2 options for breads. So we'll just multiply 2 by 4. We have 8 times 2. We have 16. That means there are 16 possible selections of dinner for this example. Another example, this may be our last example for this video. At the local sub shop, customers have a choice of the following: 3 breads, 4 meats, 6 condiments, and 3 cheeses. How many different sandwiches are possible? So there are 4 parts for this experiment or problem. Then there are 3 options for breads, 4 options for meat, 6 options for condiment, and 3 options for cheese. 3 times 4, we have 12. 12 times 6, 72. 72 times 3, we have 216 possible sandwiches. And that's all for our introduction for probability. I hope you learned something from this video. Thank you for listening.